So this is on page 32, and it introduces the ideas of, we already know about conditional statements. We already know about the converse, switching a conditional statement, but it introduces the idea of an inverse and a contrapositive. So note what we do for an inverse. If my original conditional is if P, then Q, the inverse is going to be if not P, then not Q. So it just introduces not to the conditions and the conclusions. The contrapositive is going to introduce the word not as well as switching the conditions and the conclusions. So if my original statement is if P then Q, the contrapositive is if not Q, then not P. So something that helps me remember this, we have an original statement. The converse, I think we're already comfortable with switching the conditions and conclusions. Remember that inverse is instead of switching, we just make each of them not. And then the contrapositive, since it's like the longest, most complicated word of all these options, it means to do the most. We switch and make it not. So converse, just switch. Inverse, just make each of them not. Contrapositive, do both. It's the bigger word, we do more. So the book gives us a statement to practice with. If a figure is a triangle, then it is a polygon. And for now, let's just think of a polygon as a shape. We're going to define it later, but for now, a polygon just means some sort of shape. So hopefully it makes sense to say if a figure is a triangle, well then yeah, it's a shape. It's a type of shape. So this statement is true. So when we fill out this table, the original conditional statement, if a figure is a triangle, then it is a polygon, this is true. The next thing it asks us to do is write the converse of this statement. So we're just going to switch the first and second part, the conditions and the conclusions. So we still start with if, but we're going to write if a figure is a polygon, that's the first half of the statement, then it is a triangle. And let's stop and think about this statement. If a figure is a polygon, if a figure is some shape, we don't know what shape, but a figure is known to be a polygon, some shape, then it is a triangle. Well, just because it's some shape does not mean it's a triangle, so this statement is going to be false. If the statement is false, give a counterexample. A polygon could be, let's see, a polygon could be maybe a square or a rectangle or something like that. Could be a square, right? It doesn't have to be a triangle, so this statement is false. The inverse of this original conditional statement. So we have if a figure is a triangle, then it's a polygon, so we're just going to make them both not. So it's going to say if a figure is not a polygon, then, oops, sorry, I actually made a mistake there. I want to say if a figure, I'm using this statement, if a figure is not a triangle, then it is not a polygon. And now we want to think, is this true or is this false? If a figure is not a triangle, does that mean it's not a polygon, meaning some general shape? Let's think of some shapes that aren't triangles. So if a figure's not a triangle, well, it could be a square. Well, a square is a polygon, making the second part of this not true. So just because a figure is not a triangle does not mean it's not a polygon. So this is a false statement. And we would say a square is not a triangle, but is a polygon. Okay, a square is not a triangle, but it is a polygon, so it's a counterexample to this statement. Okay, so far, we can write the converse, we can write the inverse of a statement, but it doesn't mean that they're also going to be true. In the contrapositive, we're going to take this original statement, we're going to switch it, and make it say not for both of them. So, if a figure is not a polygon, then it is not a triangle. So this is saying if a figure is not a polygon, so it's not like a typical shape, that's how we're thinking about polygon for now, then it's not a triangle. Well, let's think. A triangle is a type of polygon. So if I'm telling you it's not even a polygon, it could not possibly be a triangle. So this statement is true. And that's how we get through this table.